All right, so this isn't a nitroglycerin, but this is a dopamine infusion, and I think it follows the same. It's the same type of question where you are converting micrograms kilogram per minute to milliliters per hour, and so there's a couple of factors here to do that, and you'll definitely see this next semester. But you might see it this semester, so it's worth looking over. Where did I put my pen? Okay. So all right, so for this question, what you're going to end up doing is you're going to take anytime you have weight, you have to account for the patient's weight. So I'm going to take that 70 kilograms that's listed there, and I'm going to multiply it by what they give me, which is this 5 micrograms per kilogram per minute. Okay. So if you're ever stuck on these types of questions that are weight-based questions, just remember to multiply the kilograms together. So the micrograms per kilogram times the patient's weight in kilograms, and you should be on the right track. All right. And so what we'll get is 350 micrograms per minute. Now, it tells us that we're looking for an infusion. Now, one of the things you learned about last semester is that your infusions come in 2 varieties, milliliters per hour or drops per minute. We're not dealing with drops here because if we were, it would say something about microtubing or it would give me a drop factor. No drop factor is given, so we're going to be looking for milliliters per hour. We have a rate. It's 5 micrograms per kilogram per minute, but we want to know milliliters per hour. So the first thing I recommend doing is once you account for the patient's weight, you need to convert minutes to hours. Again, there's a variety of ways to solve these types of questions. I'm just telling you what I would do. And as long as you're getting the same answer or the correct answer, then you're doing it right. Hopefully I can give you some confidence in that. All right, so 350 times 60 will give you 21,000 micrograms per hour. And all I did was it converted minutes to hours. That's all I did there.
Are you able to, since you have to get like 400 milligrams, are you able to do 350 converted to milligrams before you do this step, or you must do this step before?
So it's up to you. So I'm glad that you noticed that you do need to convert micrograms to milligrams or convert milligrams to micrograms, that you need to do that step. So you could do it before or you could do it after. I usually do it after because I like to have a nice big number to convert to milligrams, but it's completely up to you.
Okay.
Yeah. So that's actually the next step I would do is I would take that 21,000 micrograms and I would just convert it to 21 milligrams. Right? Because all I did was move my decimal point over 1, 2, 3, and that's how I got 21 milligrams. Then I would just multiply. Now this is where like you would do like what you were saying, like the 0.4% normal saline, and then it's heparin, or if it's insulin, you're just going to convert now your milligrams. So in those questions, like insulin and heparin are in units for dopamine, and I imagine for nitroglycerin, it's going to be in milligrams or micrograms. So you're just converting milligrams to milliliters. So for this one, it's 400 milligrams per 250 ml. Then you just 250 times 21 divided by 400. And you'll get 13.125. And you would just round that to 13.1 milliliters per hour. So even though I don't have a good question for you on the 220, 230 test, practice test, this could be used in place of that. And you know what I'll do? I'll actually I'll add this question to the packet, to the 220, 230 packet, because I can do that.
Thanks.
Yeah, you're welcome. I'm going to go ahead and go back to the 220, 230 packet, and then I'll just add it to, I'll add it below the, this stuff here. And then I cleared out the question. So, I mean, we can even say this is order nitroglycerin. We can just change. It should be the same type of question. Okay. The thing is, like, the order and all that kind of stuff might be different. But this way you remember that that's what this is. Just a variation. Obviously, nitroglycerin would be completely different, but you're still going to be, it's going to look similar to this. So, and obviously they won't highlight the the answer, the important steps for you, unfortunately. All right. So how are you doing with like 22 and 23? Are you okay with those?
Yeah, 24 and 25 were my struggles.
Okay. So, well, first of all, 22 and 23 is good because that is part of the heparin infusion. Okay. Being able to convert units per hour to milliliters per hour. If you can do that, you have most of the battle conquered when it comes to the heparin protocol. For 24, so I already had this worked out. Did you get to the 20 hours?
Yeah.
Okay. You're 220, 230, right?
Yes.
Okay, I just want to make sure I'm looking at the right pack. Okay. Yeah, so yeah, you got to 20. So if you got to 20 hours, and then this is the trick, right? It says if it starts Monday at 8 a.m. So what I did is I just converted that to 0800 because you might see that as in military time.
Mhm.
If it were 24 hours, right, it would be Tuesday at 8 a.m. But we only went 20 hours, right? So all I did was I subtracted 4 from the 8 a.m. and that will give me 4 a.m. Does that make sense? On Tuesday.
Okay.
Yeah. So just, yeah, you're going to have the old, minute, hour, hand clock, spin it around. I'm just saying in your mind and go from Monday to Tuesday, knowing that we're going. And then, like I said, I use 24 hours as my gauge. You could have done 12 hours, which would have been 8 p.m. and then another 8 hours. But that, I think the easier route was just going 24 hours and then subtracting 4.
Okay. That's a good tip. Thanks.
You're welcome. All right, let's look at the heparin protocol. So I'm going to go ahead and I'm just going to delete what I already wrote. And I'm also going to change the patient's body weight for additional practice. Okay. Okay. So first of all, on your test, let me just pull this up here. There we go. So on your test, you're going to get two questions that will equal one question for what's called the heparin protocol. Okay. The 2 questions are going to be calculating a bolus and then to start an IV. And it's either going to be this scenario where it's the initial bolus and initial IV, or it's going to be after you recalibrate, after the patient's been on the medication for 6 hours, you're reassessing, right? You want to know, do we need to increase, decrease, or leave it alone, or take them off? And so that's why you'll see that written out. But so on the practice, I gave you 4 questions. But on your actual test next week, you'll have 2 questions. So just want to clarify that.
That's so funny you say that because on again, the student manual, it says heparin bolus, weight-based calculations, and heparin infusion calculation 4 questions. Are those 2 different things?
Right. Well, and then the questions above here, this is one of the heparin infusion type questions. So this would count as one. Yeah.
Okay, so we'll have like 2 of those and then like 2 of those.
Correct.
Okay.
Yeah. And my guess is you'll only have the one heparin protocol. If you go to I think it's the Boyce. Yeah, if you go to the Boyce 220, 230, they have another practice and they do the heparin. It's like written up a little bit differently, but you would solve it the same way. So if you want a little extra practice, it's in the Boyce folder, in the OneDrive folder, and you're welcome to look at those too.
Okay.
All right, so let's talk about this because this is the first time you're seeing this. When you are looking at the bolus or the heparin protocol, these, like where it's numbered 1 through 15, those are the steps of the protocol that you would probably see, like, you know, in this particular, in the cardiology, like, you know, department, in the cardiologist's office, in the ER, or in the wherever, you know, in the hospital, or it's in your chart, you know, it's a reference. Okay. So you're not doing all this stuff. That's actually why I crossed all this out, is because that's just what you probably would be doing in a clinical setting, but we're talking about just the math. Okay. So the math is, we're just going to take the patient's weight, then we're going to apply that to what the protocol says. So the protocol tells you to bolus the patient with 80 units per kilogram body weight, and then to start a drip at 18 units per kilogram per hour. Okay. And then it actually repeats that information right here in step 10 of the heparin protocol. If you go to the Boyce review that was put together, they basically eliminate all this extra stuff, and it's just what you need to know. So I originally put these together. I mean, most recently 2015, 2016. And I just Google searched heparin protocol because they said they wanted some heparin protocol questions. And I should have just deleted all these things and just kept it simple for you guys, but I didn't do that. So I apologize, but it is what it is. And this is how you'll see it, because I don't think they've changed it yet either, but maybe in an updated version, we'll update all these and it'll be a little bit cleaner. Okay. So what we're going to do is we're going to do this. Now, the reason I'm changing the patient's weight here this time around is because there are, you could actually see me work out the 110-pound heparin protocol multiple times on the YouTube channel. So I figured I'd give you a fresh one. So let's say it's a 189-pound individual. Okay. All right. So when we talk about bolus, it tells us how to start our bolus. When we talk about drip, it tells us how to start a drip. The other piece of information we need to know is what do we have available? And that's actually what we have written here. We have available 25,000 units in 250 ml. That's our IV. And then we have our bolus is 1,000 units per ml. So we have that information there. And then you're going to see me reference that as we kind of, as I go through these questions. So step 1 is, I want to know how many kilograms that is. So I'm going to take 189, divide by 2.2. I'm going to get 85.9090 repeating. So we're just going to say 85.9. Okay. Now, this just tells you the details. We just did this as a preliminary step. It's down here that we're answering questions. So the first thing it tells me to do is to calculate the number of milliliters to administer for the bolus. So the bolus, remember, is 80 units per kilogram. So I need to take the patient's weight. What did we say that was? 85.9. kilograms. times the 80 units per kilogram. So 80 times 85.9 gives me 6,872 units. The next thing is we need to convert units to milliliters. In order to do that, I need to know how to go from units to milliliters. If I look in the protocol where it tells me what I have available in the bolus dose strength, notice it says 1,000 units per milliliter. So that's what I'm going to use. 1,000 units per milliliter. When I do that calculation, I'm going to get an answer of 6.872 milliliters. And I'm just going to go ahead and round that to 6.9 milliliters. So I'm just taking care of the rounding. So you'll get 6.872, round that to the nearest 10th, 6.9 milliliters. Any questions on calculating the bolus?
No, I'm good, thanks.
Okay, no, you're welcome. And if you do, just chime in, okay? All right. The next question is, now we're going to calculate the infusion. So we're going to take, well, first of all, the infusion, it tells us to start an infusion or a drip rate at 18 units per kilogram per hour. Anytime you see that kilograms, you know you're going to have to account for the patient's weight. So I'm going to take that same patient, 85.9 kilograms, multiply by the 18 units per kilogram per hour. That gets rid of kilograms. 85.9 times 18 gives me 1,546.2. And that's units per hour. Now, again, I don't want units per hour. I do want milliliters per hour. So what I'm going to do is I'm going to take my, I need to convert units per hour to milliliters per hour. And this is where number 20, question 22 or 21 and 22 was helpful above, or a few questions above, is because you've already practiced this. Then I go and I look at my available. I look at in step 2 of the protocol, or just up here, or it will be stated for you. It tells you that heparin 25,000 units and 250 milliliters half normal saline. So that tells you where that is. And that the reason we use that information for the IV is because it is, or for the infusion rate, is because that's the IV. The other thing is the bolus dose. We only use bolus dose strength with the bolus dose. We only use the heparin strength, or the infusion strength with the IV information, which is the 25,000 units and 250 ml. So I'm going to take my 25,000 units right down here, 250 ml right here. And then I'm going to get an answer of 15, or I'm going to multiply 1546.2 times 250 divided by 25,000. I'm going to get an answer of 15.462. So 15.5 milliliters per hour. So I just round it up. All right. So that's how you do the infusion rate. Now, the next step is it tells you or it tells you, and then again, this would be a secondary question. It would be a completely different question. So most likely this is what you'll see on your test, is just to calculate the initial bolus and then calculate the initial infusion rate. However, now you'll also know how to do this if it came to it. So the next thing it says is, after 6 hours, we reassess the patient. We find that their APTT is 43 seconds. I'm going to come back up into where it says steps 11 through 15 in the protocol. For steps 11 through 15 in the protocol, you're just going to look at what it says to do, and you're just going to look at the APTT, and you're just going to line it up with what they tell you. So if it told you 100 seconds, then you would do, this step. If it told you 80 seconds, then you do this step. If it told you 50 seconds, you do this step. But it said 43 seconds. So 43 is right in the middle of 36 and 44. So we're going to follow the steps outlined here, which says to rebolus and to increase the rate. So we're going to rebolus with 40 units per kilogram and then increase the rate by 2 units per kilogram per hour. So let's do the bolus first. Now, if this were a whole number, like let's say it was 7 and you're just doing half, or if it was 8, you would just divide by 2 and you'd pretty much be done. But also keep in mind, you may not have done the initial bolus. So it's good to practice as if you hadn't done it already. So we're going to take the same patient, same weight, the 85.9. One second. Just double checking something. Oh, okay. I'm going to take the 85.9 kilograms times, now it's 40 units instead of 80. So 85.9 times 40 gives me 3,436. Again, that's units. I don't want units, I want milliliters. So I'm going to use the bolus dose strength again, because that's what we're calculating, right? Is a new bolus. And I'm going to get 3.436. So I'm just going to say 3.4 milliliters. So 3.4. So you could see that you wouldn't want to necessarily divide it exactly in half, because you might get like 6 point or 3.45, and you might be tempted to round that up, but 3.4 milliliters would be the new bolus dose. So you would rebolus them. You would, the port there on the IV, you would rebolus with a heparin, like almost like a boost. And then you would, then you're going to adjust the infusion rate. So let's talk about adjusting the infusion rate. So the initial infusion rate was 18 units per kilogram per hour. And it tells us to increase it by 2 units per kilogram per hour. So what we're going to do is we're going to increase it to, we're just going to add them together to 20. Okay. So I just want to make sure you know where I'm getting that 20 from when I write it down here in just a moment. So I'm going to take the same patient, same weight, 89.5 kilograms. Did I do that wrong? 85.9. Oops. All right. 85.9 kilograms, not 89.5. Now I'm going to multiply, instead of 18, I'm going to increase it by 2 to 20 units kilogram hour. That'll give me 1,718 units per hour. Again, I don't want units, I want milliliters per hour, but you already know how to do this conversion. Go back to our IV, same IV they've been on. If anything, we're just adding more 250 ml bags as needed. I'm going to get 17.18. So I'm just going to round that to 17.2 milliliters per hour. And that is how you would do the heparin protocol for a patient that weighs 189 pounds. Say 189. Yeah, 189.
I had a question about the strong, like question 21.
Yes.
When it says strongest concentration, does it mean I have to solve every single one and then what the biggest answer is, or the 1 million because that's the biggest?
You just need to solve the one that's the strongest. So in reality, we should be asking you a question that looks more like I don't have them here. But there are other reconstitution questions at like Boyce and North and South that are a little bit more I think it's a better question. But for these questions, it's just you're just looking for the strongest concentration. So it's, do you know to ignore the milliliters diluent added? That's why I crossed it out.
Yeah.
And then do you know to find which one's the strongest, right? So 250,000 units per milliliter is the least concentrated, and then 1 million units per milliliter is the most concentrated or the strongest concentration, which is why you would just use that. So you don't need to solve for the other two.
Oh, okay.
Good question.
And that goes the same for number 20. You just solve for the 20 instead of you don't have to do anything with the 5 and the 10.
Correct.
Okay. And can you show me how to mark the syringe one more time, please?
Sure. So, oh, I think that's up here. So for the syringe, so keep in mind, like when you do this question, make sure you select the right syringe. So this is going to be, this is always, at least this graphic is always this. And the reason you're picking it is because it has units listed. So you're not trying to guess milliliters or cc's or anything like that. You're going to administer insulin units with an insulin unit syringe, and they'll be listed in units.
Okay.
So it tells you that you have 10 units of regular insulin, 40 units of U100, select syringe A or B, and then mark the syringe with an arrow indicating two things: the solution amount to be drawn up first and the correct total medication level. So what I do is, before I do anything, if this is a paper test, I'm writing down that I'm doing 10 units first, and then that it's 50 units total. Then the way they want you to mark the syringe is your first arrow should be at the, because they don't know which one's first or second, it's going to be the total amount. The what is drawn up first is actually going to be right here. This is the regular. So I'm just writing R, because when you drew this up, right, you drew it up first, the regular first, which means between 0 and 40 is the NPH. Okay. In reality, it all mixes together, which is why I'm not a big fan of this question. And I've also seen, like, when they do this as a Blackboard test, they usually just tell you to mark the total and then make sure that you're able to mark that.
Why would you put the regular arrow by the 10?
Because remember, when you're doing the procedure of drawing it up, you're going to pull up the regular first. So the first 10 units are going to be closest to
Okay.
the plunger end of the syringe. Then the second pull is going to be the remaining NPH. So that's why. And like I said, in reality, it mixes all together. But if you're marking the syringe, and let me show you, I have a graphic that I pulled from one of the textbooks that is sometimes helpful to look at. All right, so this is from one of the textbooks, and you can see how they mark it. So here's the regular insulin is here between 30 and 40. And then the NP or the N, Humulin N, is between 0 and 30. So that's why it doesn't make sense to me to make like 2 arrows unless you're making them like this. But this is how they want you to mark a syringe, as if it's full and as if these are separated, but in reality they mix.
Okay.
Yeah, I don't make the rules, so I'm just telling you what I've been told. So does that help to clarify a little bit of how to mark the syringe?
Yep. Thanks.
Okay. Yeah.
Can we do 17, please?
Sure. All right. So 17 is a good one to ask about because 17 has some extra information you don't need to know. So the first thing that you need to know, as far as when we do flow rates, just remember all we need to know is volume and time. Ultimately, we need to know milliliters per hour or drops per minute. And what will tell me, if it doesn't otherwise tell me to calculate, drops per minute, the other thing is if it says there's a drop factor, then we know we're doing drops per minute.
Mhm.
So if I know I'm doing a flow rate question, one of the first things you can ignore is the strength. Okay. The reason being, if I have a red car and if I have a blue car, as they're both, if they're both going 30 miles per hour, it doesn't matter. Like if I'm wondering how fast they were going, it doesn't matter which car we're talking about if all we're asking is how fast were they going. Now, if I wanted to know, like, a little bit more details, or like, let's bring it back to nursing. Do I want to make sure I'm giving the patient the correct medication? Yes. The correct strength? Yes. But when we're calculating flow rates, all I care about is how is it infusing? So that's why I immediately cancel out the 200 milligrams. That just tells me how much is in the IV. I care about how fast the IV is infusing for these types of questions. So 75 milliliters, 30 minutes. You can convert minutes to hours, but don't do it because it's a wasted step because your end result is already in per minute times your drop factor of 10. And then you'll get, 75 times 10 divided by 30. 25 drops per minute. You got it. The trap with this question is trying to incorporate the 200 milligrams.
Right. That's what I'm like, there's no milligrams in this. You can't convert milliliters to like, there was no way to do
Nor,
that.
nor do you need to. So that's kind of like the trick with this question. And that's what they want you to be able to, rationalize or reason through. Oh, okay. I would want to convert this to this because of, or I don't need this information because it's just extra information. It's just telling you what the drug is and what the strength is, but they're asking you what the rate of infusion is. So, yep.
Is that the same thing with question 13? Like, we don't actually need to know the patient's weight. You just can use the 5 milligrams and the 4 milligrams.
Correct. Yeah. So the patient's weight is just extra information. So you might sit there and go, okay, I'm going to convert the pounds to kilograms. Now what? Exactly. It doesn't matter.
It says 5 milligrams per kilogram, then you would have to use it.
You got it. Perfect.
Okay.
Yes. Yeah. Then you would incorporate the patient's weight. Exactly right.
Okay. I think I'm good for tonight. Thank you so much, Dr. Rad. I appreciate it.
You're welcome. I'm glad to help. And I'll be here on Tuesday and Thursday. If you need any extra help, you can email me. And if I don't hear from you, good luck on your test.
Thank you so much.
You're welcome.